everyone. In today's video, I will be covering a topic, indeterminacy of structure. So, indeterminacy of structure is of two types. The first one is static indeterminacy. Static indeterminacy. And the second is kinematic indeterminacy. Okay, and the static indeterminacy is denoted by the term ds, and the kinematic indeterminacy is denoted by the term dk. Okay, so here this, in case of the static indeterminacy, in case of this static indeterminacy, they mainly focus to know the external and internal forces. And in case of kinematic indeterminacy, the main focus is to know the rotation and displacement. Now I'll briefly discuss about the static indeterminacy. Okay, so now comes to the static indeterminacy. So, and it is denoted by the term ds. So to find the static indeterminacy, we have an equation that is ds is equal to total number of unknowns minus total number of equation of equilibrium. Okay, so I'll take the example of a simply supported beam. So in the simply supported beam, what happened, one side is hinge support and the other side is roller support. So in case of the hinge support, what happened, there will be a two unknown reaction. One is in direction of, it's a vertical reaction and it's a horizontal reaction. Okay, and in case of the roller, suppose there will be only one unknown reaction and that will be in the direction of y, that is vertical direction. So here in this case, the total number of unknowns, okay, that is 3, and we know that the total number of equation of equilibrium is 3. So ds is equal to total number of unknowns is what, 3, that is 3, and minus the total number of equation of equilibrium is 3. So 3 minus 3 is equal to 0. So the degree of this one, the degree of static indeterminacy for a simply supported beam is ds is equal to 0. Okay, now I'll take another example, that for a fixed beam. So this is a fixed beam, and for a fixed support, what happened, there will be a 3 unknown reaction in this side, that is vertical, horizontal along with the moment, and from this side also it will be a vertical, horizontal along with the moment. So now we have a formula for finding the degree of static indeterminacy, that is nothing but the total number of unknowns minus total number of equation of equilibrium. So for this fixed beam, what happened, ds is equal to total number of unknown reaction is 1 2 3 1 2 3, the total number of reaction is 6, minus total number of equation of equilibrium is 3. So the answer will be 3. So we can say that the degree of static equilibrium for a fixed beam is 3. Okay, now there are some condition, okay, to check the stability of the structure. So how to check the stability of a structure? So stability of structures can be checked by using these conditions. Okay, condition number 1, if ds is equal to negative, if the answer of ds is nothing but the degree of static indeterminacy comes to be negative, that means the structure is unstable. Okay, and if the ds value comes to be 0, then the structure is just stable, or we can say that just rigid. And the condition number 3 is if the degree of static indeterminacy is greater than 0, then the structure is over stable, or we can say that it's a over rigid. So I'll give the example for those conditions. Okay, now I'll take one beam where both the sides are supported with a roller. So here how many unknown reaction will be there for a roller support? 1, and here also it will be 1. So we know the formula for degree of static indeterminacy is equal to what? The total number of unknown reaction. Total number of unknown reaction for this case is 1 and 2. 2 minus total number of equation of equilibrium was 3. So answer comes to be minus 1 here. So now in this case what happened? The degree of static indeterminacy is minus 1. So what we said was if the ds value comes to be negative, then the structure is unstable. So this type of structure is unstable structure. Now for this case, for another case, I'll give the example. I'll take one beam, one is support, one is a hinge support, and the other side is roller support. So for this condition what happened? Number of unknown reaction for a hinge support is 2, that is one is vertical and the other is horizontal, and for the roller support it's a vertical. Okay, so now to find the ds is equal to total number of unknown reaction. For this case is 1, 2 and 3. So number of unknown reaction is 3 minus total number of equation of equilibrium is 3. So ds is equal to 0. So if ds, degree of static indeterminacy, is 0, then it will satisfy which condition? This condition number 2. Then the structure is just stable or it's a rigid structure. Okay, so now again I'll take the example, another example, that is condition number 3. So I'll take the example for a fixed beam. So in the fixed beam what happened? There will be a 3 unknown reaction. One is from for a vertical direction, the other is horizontal along with the moment. Here also it will be same, one is in the upward direction, horizontal direction, and the moment. So degree of static indeterminacy is equal to total number of unknown reactions minus total number of equation of equilibrium. So in this case what happened? Total number of unknown reaction is 1, 2, 3, 4, 5 and 6. So there is 6 unknown reaction minus the total number of equation of equilibrium is 3. So ds is equal to 3. So degree of static indeterminacy for fixed beam is 3. so it's equal to 3, right? So here what happened, 3. So it satisfied this condition because the ds value was 3 and 3 is greater than 0, right? So that structure comes under over stable or over rigid. Okay, so in the next video I'll continue with this only, that is static indeterminacy. Okay, thank you.